Hello everyone, Dr. White here with a few tips on getting started with the Section 5.1 DA on estimates and the variability in estimates. Looking at our studio, you've been busy with various things. Most likely, it might be time to kind of clean things up. So I noticed my plotting window here is really big. Why don't I just make it horizontally smaller and vertically smaller? Okay. And we should probably just look back into files. As far as the global environment is concerned, I bet I don't need those variables I've created. So let's clear it out. And I don't think I'm going to need to look at a Madge pop. So I'll close out that data view. And let's pick up the DA. Well, let's first make sure, do we have the slides for section 5.1 open? Yeah, we do. Okay. Now back to our studio and pick up the DA. /com Dr. White stuff, Mat 111, DA. OS 5.1, estimates and variability. File. Oops, wrong file. File. Save as. ... Point back home. Find submit. Double click on it. Looking inside submit, save that DA. Now you have your own copy. Let's knit it up, see what it asks us to do. We'll pop it up big for now. Well, it says we need to have Tiger stats attached. I know that I do, so I'll go ahead and look into the one question group called unexpected expense. So it's based on a problem that you can find in the textbook. Here's the scenario. In a random sample of 765 adults in the US, that's a little typo there, the word of should be right there, 322 of those 765 adults say they could not cover a $400 unexpected expense without borrowing money or going into debt. So you have to process this a little bit, take your time, think about it. Once you've thought about it, you realize you've taken 765 people out of the population, you've taken a sample of that size, and you've asked each of them a yes-no question. Could you cover a $400 unexpected expense without borrowing money or going into debt? 322 said no. And it looks like you're counting up the number who said no, that the no answer is like what you're interested in. You want to know what population is under consideration in this data set? You can tell what population by looking at what the sample is taken from. This is a random sample of 765 adults in the US. Our sample is being taken out of all adults in the United States. So that's going to be your population. You can answer that here. What parameter is being estimated? Is it a population mean mu or a population proportion p? It's one of those two choices. By the fact that this is a yes-no question, I think you'll be able to consult your slides in the first part of the slides where we go over parameters and estimates, and you'll be able to figure out which one of these is the case. What is the point estimate for the parameter? Once you know what parameter is being estimated, then you know what point estimate you've got to make. If it's a population mean, then you need to compute a sample mean. If it's population proportion, you've got to compute the sample proportion from your data. And so what you'll do is you'll go into the code chunk. that's provided in the answer section, and you are going to replace this little comment with some math computations that compute the point estimate for the parameter. You don't actually have to write the answer to your computations. That will be provided when you knit up the document with the computation here in the code chunk. And you'll be able to find it right away for yourself just by pressing run current chunk once you put in the right computation. What's the name of the quantity that we can use to measure the likely amount by which the point estimate might differ from the parameter? Study and find the correct name for that quantity. It is a name, not a number. But in the next part, you are going to compute the actual numerical value of that quantity, of that give or take figure. And that'll be done where you replace this little comment with the R calculations that compute that quantity. Last one, a cable news pundit thinks the value for the population parameter is actually 50%. She thinks 50% of the adults in the population could not cover a $400 unexpected expense. Should she be surprised by the data that we got? And you are going to, again, fill in an R code chunk with some calculations that help determine whether such a person should be surprised. So study the concept of surprise in the slides. That's just before page 28 of the slides. And then enter your computation here, and then you're going to have to talk about what that tells you here. So not a real long DA, but go ahead and get at it.